Yeah,
Yep,
that's right.
there we go.
So
let me re-ask the question.
yeah.
How would we do virtualization in Aries? Because we have roads in Var, we don't have roads in in Aries. So in Var, we can just obliterate the road, long jump back to the home road. In I believe it's in the signal handler, right?
Yeah.
Yeah, and then we don't have roads and we can't long jump in Rust.
So virtualization only actually like it can only catch deterministic errors. So like we leave. So when it says in the signal handler, the signal handler actually can only jump out of all of your interpreter. It can't just jump out of one layer of it on its own. Um, so what actually I think we could do is just um, when we detect a deterministic, I forget, does our interpreter detect deterministic errors now? Right now, those are usually Nock 00. I don't know if our interpreter recognizes that.
Let me take a look. Oops, where is it?
I think it's 00.
Check for the different panics. I don't think it does. I think it just panics. I'm looking at the Nock 0 axis.
Okay. Then what we could do, make sure 00 is what I expected to be. Yeah. So like Mink's behavior or its specification in Hoon is that if you do a Nock 0, which is slot, look up an axis for any axis that doesn't exist, including 0, because that's not going to exist in any noun, then it's going to give a stack trace immediately and deterministically. And so that's what like ZapZap produces. And WhatGal and stuff will keep producing that as well. And that is basically the way that we detect deterministic errors. And the virtualization that we need is just those deterministic errors for something like Mink. We need something more for gathering those stack traces in general. But if we attack only deterministic errors first, I think that's doable.
So in the context of virtualization, we have a Nock formula that basically says, then run this other Nock formula, and if that fails, that's kind of like a valid result in a way. Whereas right
Yeah.
now, we have no way to catch that. So we need some way to signify that, like, come back to this and continue work if that fails. Because if something
Right.
fails in virtualization, you can keep the program running. You don't
Right.
just go back
It's
to the
like
queue.
failing in Canada. You didn't fail in real life. No,
Exactly.
um, uh, right. Which, if we, so the true marking interpreter usually, doesn't call itself. It doesn't literally recurse. It puts stuff onto an explicit stack and then goes back into it. And so, if
Right.
instead
Yeah.
we actually call interpret, then we could make interpret recognize that and just
Right.
return it.
Yeah. If we just set up a second arena, a second 2-stack arena, and just run in that, and then return back to the first arena, which is from where we called it, that should work, right?
That should work. Yes, we may be able to use the same arena if we keep track of basically how far we are in this virtualization context, like how many steps there are there so that we can jump them all at once, basically do our own little long jump.
Mhm.
But it's probably easier to just build it, to just do a second arena for now, to get something running, and then we can have, later on we can be like,
Yeah.
okay, we can do a single arena.
Yeah, for now, I think it'd be nice to just get something running. But I think you're right.
Yeah.
How complicated does that even have to be? Could it just be a global that just tracks the root arena pointer or something, and just come back to here?
Well, it can't be quite global because you can virtualize within virtualization. Like you can nest
Right.
them.
Well,
But,
then wait. Then we would never
but it could
long
just be
jump
at
all
the
the way
top of
back.
the.
'Cause
Uh,
we're-
right. We would only ever long jump one step at a time.
Yeah. So then it doesn't even matter about long jumping all the way back, right? Because if you're virtualizing within virtualization, then you do want it to like go back one layer and say, oh, this failed.
Yeah.
And
Yeah. But we need to somehow keep track of where on that stack we need to jump back to. But that's actually easy. Just store it at the top of the function, and when you return it,
oh.
restore it.
Sorry.
Right.
I see what you're saying now. Like the stuff that we had before in Ed's version, now the new one in John's, are like, what are the frame pointers and stuff that we're coming back to?
Yeah.
Right.
Yeah. Exactly.
Yeah. Okay.
Right.
Yeah. I see
But
what
that
you're
actually
saying.
should be really easy, right? Because
Yeah.
it should be just you just store a copy at the beginning and restore them on deterministic failure.
Yeah. Actually, becomes interesting because now this gives us an actual use case for the stuff. I think, at least off the top of my head, I think for the previous frame pointer, previous stack pointer, previous alloc pointer on the most senior frame in a two stacks thing. Because right now we just fill them with nulls because it means nothing. There is no
Right.
more senior frame than this frame. Whereas now it can be go all the way back to this other frame.
Right.
Sorry, in this completely
Unless
different
they're
arena.
actually nulls, and if they are nulls, then that means
Yeah, then
you're
we're
at
on the
top
home road.
Right.
All
right. And you should
roads
just send it
lead
over
to the road system.
Yeah. Also, will read home.
What if we just reinvent Ver from first principles?
Exactly. Okay, I think this scheme makes sense. And the way that I would sort of frame that task, even prior to integrating it with the stack trace stuff, is basically jet mink, right?
Yeah.
If we can have a jet for mink, then we integrate with stack traces in two ways. Number one, obviously the stack traces would call mink to print it out so you can send it to the king. But also mink itself, as implemented in Ver, and there's been lots of talk about changing this, but as implemented in Ver, mink grabs those stack traces and returns them directly. Which the reason why that's bad, of course, is because the stack traces you get from Aries are probably going to be different from the stack traces you get from Ver. It certainly depends on what jets you have installed. So that shouldn't really be coming into your Nock context. But I don't know. We'll see whether we actually want to.
Sorry, I don't think I understood. Could you repeat that?
So when you hit a zap, like a 0-0, you have deterministic error, and mink right now, in there, it doesn't only produce like null, yet your thing crashed. It gives you a stack trace. It says here's where it crashed, and that is formally not okay, because that stack trace depends on the vagaries of your interpreter. Your interpreter might run things in different ways. It might depend on whether turn is jetted, for example, for whether those items are going to appear in your stack trace. And so it's not deterministic.
I see.
If you replay it across, with a different interpreter, you might get different stack traces, and so that if that's the case, then it should be coming into like an event or something. It shouldn't be, or it should be just like printed out like the way SIGPAM works or something. But it shouldn't be coming into your context. But that is the way we do things right now, and it is very convenient because then you get stack traces you can print immediately. So we might just want to duplicate that behavior. But we'll
Is there a way to keep it informal? Like it's a dojo side effect?
yeah, like a SIGTAM style. So that is safe to do. The it would make the experience of your dojo look somewhat different because right now we do make decisions about whether we're going to print things. For example, there's like we don't print stack traces on AIMS packets unless you have AIMS verb message on. And that's that's in Argo. That's not a runtime flag. Although it could be, right? So yeah, there's a whole cluster of questions there that we've gone round in circles on many times, and we can just choose whatever answer we want, really. And because we don't have a right answer right now, so so that'll work.
Gotcha. Okay. That's already pretty helpful. Just because it gives me a direction to go. Before I feel on top of talking in circles, I feel like when I was talking before with Pop Rocks, Jonathan, and Ed and Joe, it's felt like we got kind of and Paul as well, into a little bit of a circle of like where do we go? It's like, well, before that we should have this, before this we should have that. Well, if we're doing this, we may as well do that at the same time. And it started getting into a much broader thing. So this is helpful for making it more bite-sized. Like, there's a tail by which to grab it.
Yeah, it's very easy to talk yourself in circles on in a metacircular interpreter, however you want to say that. Like it's very easy to talk yourself in circles because everything does kind of depend on everything, and the way that you break out of that is you build scaffolding. You say, okay, well, I don't have this, but I can build most of this, or I can build this, but it's kind of hacky, and we'll unhack it later. But it'll be enough to build the other things. And you expect to throw away a lot of code even as you're writing it, right? The mink stuff will presumably change somewhat in the presence of a different interpreter, but it's not going to change tons. And it's worth building now, even if it's all going to get thrown away, because it lets you do stack traces, it lets you build everything else. Yeah, you can definitely just build stuff with the intention to throw it away because it will have served its purpose by the time we throw it away.
For this initial version, would this be a real version of jetting mink or a sham jet version of jetting mink? Or does it even matter?
I would just do a sham jet. It doesn't matter much because like the jet gets written the same. It's just that like how it gets matched. We don't have a way to match anything other than sham jets right now, I think. If I'm not mistaken.
Well, that's kind of oh wait, yeah, you're right, because it's going to be a fast jet, because that's how we jet mink. It's a fast hint that just redirects to the interpreter itself, right? So it has to be a sham jet. Yeah, sorry, I got confused. I thought there might be a different hint for it. And then if there's a different hint, it's like, well, I can just add them. I've already added all the stack trace hints. But
yeah, no, it should just be it should just be a regular sham jet.
Just sham for now. Okay.
Yeah. All right, I'm gonna start sharing my screen and we can take a look at more specifically what this looks like. Okay, is that big enough?
Yes.
Okay.
Let me get into a better work environment, one where I'm seated.
Yeah.
Instead of lounging.
Yes. Okay. So interpreter. And then does it work if I go one smaller?
Yeah, that's still good.
Okay, well, it's a little easier to have 3 homes. Then so interpret. I looked into it a little while, but I assume it's pretty similar. Is your stack trace stuff merged in here or no?
No, it's on a branch right now.
Let's see. So we're gonna end up wanting to call this. Okay, so jets. Let's see, remember how jets work. Um, we're gonna want there's just this one list basically, right? Yeah. We're gonna want a mink, jet mink, and everything else we put in jet, like jet's math, because you could at least construe them as being related to math. Mink is not. So we should probably basic. So here, let's see what this file looks like. We're just going to another one of these files. What category would you say mink is under?
Sorry, I'm trying to find jets math. I guess virtualization. Virtual.rs.
Yeah, which would have mink, mule. What else? Trying to get these up.
Muir, Mook. There's all the M's, the big M's.
Do they all have jets? They might. I think there's some like if it was like the Nock category or something, would that encompass anything more or not really?
Oh
It's
man,
mostly crypto, math, and then compiler. And yeah, not really. Virtualization is basically the right thing.
trying to catch. I'm trying to open Vera on mine to double check.
Uh-huh.
You can look what you're looking at. Where is Jets E?
Yeah.
What else is in there?
I use
Oh, yeah.
tree,
Crypto,
so you can get them all at once. But yeah,
Mink, Mole, Mule, Scott's. Well, yeah. So I see what you're saying. What is? You're saying a Nock category?
yeah, but I don't think anything else really falls in a knock. Maybe it's just virtualization jets.
I guess the var grouping doesn't really make sense because it's based on, well, first of all, it's out of date with the current separation of Hoon.
Yeah.
But then also it's just a mix, like you were saying. The jam and Q are in here, virtualization's in here, JSON jets are in here, all the crypto jets are in here.
Yeah. It's not clear to me what that separation gives you in there. Like the idea of it is that it's layering, that the higher ones depend on the lower ones, but it doesn't seem like a useful distinction to me.
I asked Joe about it
Categorization.
semi recently, and he said that like it used to be well organized based on that layering, like you just said. Like the higher ones depend on the lower ones, and at the very outer ones is the Zeus jets. But like the kernel's being reorganized, the jets are being reorganized. The reorganizations took place independently of each other, so it's kind of out of date. So on that note, just call it like, I don't know. I think, what did you choose for now? It's a little small.
Virtual.rs.
Yeah, virtual.rs. I think that's fine. Naming doesn't matter. We'll start a debate about this later.
Yeah, seems all right to me. This middle, I forget. With Rust, does that need to go into some other file? It does, as long as it gets used, right?
I think as long as it gets used, we should be good.
Oh,
We need the crate GDB, I think.
Here. Yeah. Then gonna have like all jets have this type, and so I don't really need all these. Remember, almost certainly don't need the big stuff.
Take your time. I'm trying to catch up to where you are right now. but on my end.
What do you mean catch up? Like,
I'm just trying to replicate it on my end so we can kind of work in tandem, but in our own environments.
okay, yeah,
I think I'm
Yeah.
there now.
okay. So mink, let's see, do I have everything I need from this file? Mink has this signature. Yeah, dude. From here. How do we do this one? Several. We just, yeah, okay. We've been doing it as this to get the argument, and then we need to break it apart.
Mhm.
Subject formula and scroll. We have a subject here, so what's a good name for that? Like inner subject or
Maybe the subject,
so?
yeah,
Okay.
virtual subject.
Yeah, that can work. Is that works right? Yeah. Or it's not 2, it's 4. Yeah. And then the formula or fall, or what we call it. Agreement. Make that. We could do it full size, like I'm remembering what the traditional way of, or the patterns that get used in the rest of the area code base is that we write out subject in the formula, so I'll do it that way.
Mhm.
Yeah. And that's 5, right? Yeah, and then this is 7. Um, for the moment, we'll just probably ignore the scribe handler, but also it wouldn't be that hard to actually do something with it, because the main thing you need to make the scribe handler work, if you're given a function like this, is to be able to call mink on it. So once we have mink, it'll be straightforward to just recurse.
Mhm.
Okay, and
Right.
then
Hold on, let me.
Yeah.
So, why is it 4, 5, and 7?
So this is the argument that, so 2 within 2 is 4, and then 3 within 2 is 5,
Oh,
and then oh, you're right. Sorry, that's not 7. That's 3. But this is 2. This is 3, and then within 2, that's 4,
oh, yes.
and then
Sorry.
5. Yeah.
Yeah, I misread the argument. Yes, 4, 5, 3. I saw a subject
Yeah.
formula, and I didn't see that it was the buckhole with the scry handle.
Oh yeah. Probably short enough that it probably could go in a simple line, but also reasonable to keep them separate for, it makes them feel more distinct. Yeah. Okay. And so that's going to produce is tone, which is this. Always either 0 with the answer, 1 with some kind of description of something we blocked on, which is only going to come from a scry, or trace, which is what's going to happen if we fail deterministically. Okay, so then at a high level, we're going to want to make a call to interpret. Interpret itself is going to have to be modified some, but it's going to be something like stack, we don't have the newt here. So think about that.
Can't we just pass for the same thing?
We can, but we don't have it.
If we don't have to, yeah. Oh,
Or no, sorry, we don't have it, is what I mean.
Yeah.
It's not in our arguments.
Right.
Because let's see, because it gets into here, and then we go to
We have the newt in the jet, so the jet can do it.
but it's not in
Sorry, the hint in the hint we have it.
Okay, so how hard would it be to? We want to pass that into each jet.
Oh, I see. Right, because we have a generic sham jet system right now.
Right. I mean, it doesn't like we have this system of like we produce a function and then you do it, which doesn't have to be that way. You could just actually kill it. But I actually think it would be pretty reasonable to add it to the type of jet, because you might want to, for example, run a SIGPAM in the middle of your jet, and you shouldn't have to print that to your own console. You should be able to send that over the wire. So maybe we do just add the newt to the jet.
So an option newt then, an optional newt.
Yeah, it'll be the same type as this. Mutable reference to an option of mutable newt. Yeah. And then I guess the Flux format will make it the right way. Okay. We're doing that, then I just need to go into all the math ones, which we can do in a little bit, but let's write this out first.
We can get to that.
Give it a name.
Jets.
Then we just pack it. Could even add our own little, like a sig bar, like, we're going to a new road, which we shouldn't do unless it's in the human. But yeah. Okay. The idea then is that for us to recognize an error, like what we want to do basically is say, okay, now just produce res, or match on the result of interpret. What's the right pattern for that? Basically, interpret shouldn't produce just the noun. It should produce a, basically that 0, 1, 2 thing. The only question is, should that be like you could produce that as a noun and then take it apart as a noun, or you could produce it as a Rust thing. It probably should be like a Rust, an enum. That's how they do. Yeah, that's right. It's how they do tag unions, like buck-sends, basically.
I think so, but we can double check that in the Rust book or what have you. Sorry, so interpret should produce. You're saying the tag unit. We should produce that, but what should interpret produce?
There should be like something close to what Copilot says there. It's not exactly that. It's more like done noun and then block on something. So this is whatever tone says. A noun for now, but it might get more specific at some point. Or an error, it's not that kind of error. It's just error with a trace. we'll say noun for all of them right now, but
Mhm.
we might get more specific. And so the idea is that, yeah, this should produce that. Oops, wrong button.
Uh-huh.
Or anyways. Which means anywhere we return, don't return very often, right? We only return at the end, essentially. I think it needs to be something like done. And then if we want to return early, or maybe yeah,
Error. If we want to return early, we do error trace, which doesn't exist right now, but it does in my branch.
okay. So I'll just do error of 0 right now, just to, or maybe
Yeah.
a set no value or something. Which will make it easy to break in. Trying to think. Can we just early return here? Let's see. So 0, 0 is especially the one I want to look for. There are other cases that mink does catch. That really should be implicated at some point, but basically, what I want to say is, if
Shouldn't it return where it panics
formula
there?
equals 0, 0, and pseudocode basically, do we do return error?
Does it need to be specifically for Nock 00, or does any invalid, like Nock 0 for a branch that doesn't exist?
Is Nock 0 for a branch that doesn't exist? And it's also, so if you search for then 2 in the definition of mink here, you see it's also any formula we don't recognize, any fragment that doesn't exist in that noun. If we try to increment a cell,
Oh, okay, yeah.
if
So
we try to do,
it should just replace
uh,
any panic in the current interpret with an error then.
yes, I think that's basically correct.
Because I think Ed's already enumerated the cases from Mink in the Nock panic errors.
Yes, it does look like, yeah, that those are essentially here.
He's got all the other ones like
Does he have a default case?
like the Nock 6 one I think has one.
Yeah, the Nock 6 one does. He does not. It looks like he doesn't have a case for, or I guess probably the compiler or the whatever called the push formula probably has the if it's not one of them, yeah, they not opt out. So these panics as well should turn into that.
Mhm.
I don't know if any of these panics are non-deterministic. I don't think any of them are really. The thing though also is that 0, 0 is the one that we care about the most, and I don't think that this probably does catch it, but not directly. It's only in slot itself. Maybe slot should produce, like should yeah, like that's the panic that we actually care about. So okay, what's the order operations? Do we just look at 0, 0 and go from there, or do we go ahead and it's probably not a bad idea to go ahead and thread these panics through? Yeah, actually, I think we should probably just go ahead and do that. So
Sorry, so you want to thread all of the panics into slot 00?
no, into producing error.
Oh, I see. Yeah, okay. Sorry. I got confused whether you wanted to redirect them all to one place and then that place produces error.
Yeah, I don't think
I was
then
just
you
going
do that.
through them. Nock 11 does not produce an error. That one should actually panic, I think. The Nock 11 compute hint one.
Oh yeah, that's probably true.
It's the one where I think that one is an actual logic error where like it did a check on whether or not our hint is a cell or an atom, and then it sent it to go to the atom route, but it gets a cell, or vice versa.
Okay, yeah. That kind of thing is an actual panic because it's a bug in
Yeah,
the interpreter.
that's an actual bug in our code, not in
Right.
Nock logic here.
Right. Okay, so for example, this panic would be where do we do this?
Just
I mean,
error.
Copilot has the right idea, but we haven't done that.
How do you have Copilot on? Like, what is Copiloting for you?
There's a Vim Copilot plugin. It's written by Tim Pope, like the main Vim plugin guy. And I think that Microsoft just paid him to write a Copilot plugin, and it works great. I've never had any problems with it.
I'm just wondering how did it figure out the as noun thing? Like, how did it figure it out?
Because it knows that it's an error, and it sees that error takes a noun, and it sees a bunch of as nouns in the rest of the file.
Okay, so
and so
but
it's like that's probably how you convert it.
It has no actual concept about the language syntax.
Well, I mean, it knows how to write Rust. It's seen a lot of Rust in its life.
Okay, so I'm just curious.
It knows that, hey, it needs to be a noun. I see a bunch of as nouns everywhere. It needs to be noun because it's an error. But what it doesn't know is that string doesn't have a way to convert to noun.
Right. I guess what I'm asking is it a Rust specific Copilot, or is it just a Vim Copilot that like is very good at interpreting how the rest of the file looks and kind of mimicking the shape?
Yeah, no, it's just regular Copilot, like running on Microsoft servers, like it with the backed by OpenAI. It's that stuff.
Oh, okay, it's that one. Got it. So it's the same as the
GitHub one. Yes, it's GitHub Copilot. That's what I mean.
Okay. Okay.
It's just a Vim plugin that sends it off to GitHub.
Gotcha. Okay. Sorry, I was curious. I'm like, that's if it were purely just like local language, like running over the file, that's a good guess.
Yeah. Okay, so
should we just zero it for now and then?
Yeah, we do want to keep the text somewhere, but we can keep it in a comment. Okay, so I think this, and then like this, maybe something that you can find and replace if you needed to later. That's an decent pattern.
Yeah, that's what I was thinking.
Okay. We can even give these different numbers if we want. And yeah, so which it can even be an enum, but the point is that they should be the actual factors at some point. Okay. So that's the case of like actually should be an atom. It's possible we'll end up needing to do something other than like right now returning immediately. I think is fine, but it's possible that we'll need to do something other than that, like the store stack pointers we talked about.
Mm-hmm.
I don't know. I'll just do it this way for now, and then.
Oh, it's fine. Yeah, for now we're just doing it together, and then at some point there'll be a handoff, and I'll keep going.
Yeah. Okay, so slot. Option, or I forget the other one. Result. I think result is more correct, right?
Yes. Sorry, now I'm just thinking. So Nock's your axis. I'm just thinking, is it Access must be an atom. So that's if it's okay. Got it. Yeah. Sorry, I was trying to figure out. I got a little confused for a moment, but now I see. So the one we already replaced is if you try to do a cell instead of an atom, and then this one is if that atom is a zero index.
Yes, yes. Or if that atom points, like you try to knock 7 of a cell of 2 atoms.
Right. Right. The
It's
one
2
below it
even.
as well. Yeah.
Yeah, yeah, yeah. But this is if the axis is an atom. Yeah. Okay. I think result is result the right word for that?
Yeah. A result is the error or whatever. Man,
Okay.
I used to know this stuff so
Yeah.
much better. I used to know the Scala nomenclature for it though.
Nice. Okay, so I don't think just is the word. What's the is it? No. Okay. Is that it?
Let me try to pull up the Rust book on the fly.
Let's see what jets, yeah, or the actual jets give a result, so they should say it'll say
Results.
okay or error. Okay, so yes, this, but surely it's more complicated than just result, right? It needs to say what kind of error it is. Yeah. So it's result
Well, it
now.
wouldn't. It
Now,
wouldn't later, right? Because eventually it's going to be the stack trace.
what do you mean it wouldn't later?
You
Wouldn't
said
what?
that it needs to explain what kind of error it is, right? That's what you just said. Like it can't just be an error; it would
Yes.
be an enum error. But it do we don't actually care, right? Because we're going to return the stack trace, or are we trying to?
Yeah, you're right. Yeah.
Well, we could do
So
it another way.
result of that with null, then we'll let us just say error of null, or unit or whatever they call it.
I mean, we could do it another way, which is we can enumerate the errors and then push the stack trace one step higher somewhere, like in wherever interpret gets called from. That's another option, I think.
Yeah. Uh,
What's the particular value that you're thinking would be useful to enumerate the errors? Like, is there a programmatic
well,
reason
I
we might
just
want to have it?
so I mean the programmatic thing is you have to have something there, but that something can be unit, which is fine. You know what I mean? Like null.
Yeah. For now, it's the temp holder.
That seems fine. Right? You can prove it as needed. Uh, this is the other okay case, and then there's another error case. Enough. Okay, so slot produces that now. Now we do this. Unwrap, I think is the correct one, something like that. Okay, so now then slot as it gets used up here. Yeah, back here. Res now is different. I'm trying to remember what's it's like it, yeah, if let okay, right? So if
Yeah.
let okay, res equals that, something like that, right? Then do this. Otherwise, return a number.
We already
Yeah?
have. Yeah, I think that's fine. I'm just trying to remember it because we already have an error saying, oh no, but that's right. Sorry, I'm getting confused. There's error, which is our enum, and there's error, which is the other side of the result. Yeah.
Right. You could use the question mark operator if we had
Right.
a way to convert that to Nock result that it understood. I don't know.
Yeah, that's exactly
there's
what I
some
was
way,
thinking
yeah.
of.
Yeah,
That's what I was
yeah,
thinking of, but I realized that I'm getting my errors confused.
right. It would be pretty reasonable actually to make this a kind of error in that way. Make this actually okay an error, and then under error you have an enum of blocked and actually error or something.
Is
that a good? It might be a good idea.
it maybe is
Right.
blocked an error? I'm not actually familiar with block. I know it has something to do with scries.
It needs to be scried on something that, I mean, it's an error in the sense that interpret has to leave early.
Like it couldn't actually find a result.
Yeah. Maybe something more like, okay, so if we do like Nock error, then this can be, yeah, it's probably more rusty, right?
Yeah, that would probably be, yeah, a result
that'll let us,
of Nock error.
Yeah. Okay, so then the done cases, that's just okay. And then where we're looking at here, we can say, I mean, we still can't quite use the question mark operator unless we use Nock error here, which we could. I don't know. I think we should,
Yes.
or else there's some way of, or yeah, there's this, right? Impl from, like if we put that in, then we can see the question mark operator. We can say,
Sorry,
if it was,
right.
was a null. I guess if we're using error there, we can use error everywhere.
Right. So, sorry, just to make sure I follow what you're saying, we either need to replace the slot to also generate a result noun or Nock error, or we need to define a way for Nock error, the from impl, to, or we need to return another thing and then have a from implementation that will convert it to an error. That's what you're saying, right? Yeah, error as in ERR.
Right. Although I think actually this doesn't really help, because when we actually have stack traces, we're going to want to explicitly go get a stack trace here, because slot's not going to have access to the stack trace. So we're going to need this if else anyway, because the else case is going to be grab a stack trace and put that in the.
Yeah, you're right. You're right, because slot won't have access. What does slot have access to actually? Does slot have?
Just a noun and an access.
Yeah, we need to have the actual stack object for the pointers.
Okay, this should work.
Yeah.
Then yeah. Okay. The other panics kind of increment Nock 4. That's return. Wait, what do we? It's not error. It's error. Is error the right? It's a little confusing to have error. Fail or deterministic or just error.
And blocked, or what do we call it in mink? Oh, we don't. We just have 0, 1, and 2.
Yeah, success, single block, error report. Trace maybe.
Sorry, what?
Trace.
Trace. Well, returning a trace. Is that what it's called? I guess a trace.
No, not really. It's really it's a deterministic error. Yeah, I think error is fine, and it looks a little weird to have error of error, but it's fine. Right, then Nock for increment.
Yeah, nice.
Yeah, I'll use the actual text that's here, but not too far.
It's pretty good. It's pretty good at auto completing.
Yeah. Right, so it's this, except same. There must be an atom. Tree must be an atom since we're, yeah, but not 10. Also, we can't think it's an atom. Is this the one you're saying?
That was the one I was talking about. Yeah, that's the one that's an actual logic error in the interpreter itself.
Because we shouldn't have pushed such a formula. Yeah. Okay, so
Yeah, we should have gone to
same.
Nock 11 before compute hint. It's
Right.
or sorry, compute hint is the one for dynamic only.
Okay. And then push formula should also produce
Well,
that, right? Just because there's ways for it to fail there.
push formula. That'll give you that.
And then anywhere in here that it's panicking, well, so first of all, at the end of this, we
Right.
okay, no. But otherwise, anywhere that it panics, like for example here, we can do something like this. But it's a bunch of panicked. I wonder actually if I can.
So just
try and make a macro.
In the interest of time, don't worry about this because at some point you're going to hand this off and I'm going to keep going. So this is replacing all of these is doable. Let's try to focus on the stuff that.
Sure. So push formula has some call sites. Those are basically going to get what? Okay. Because they might produce an error now. And if they do, we just want to produce that all the way through.
Right.
Okay, then then where does that leave us?
So that leaves us with interpret now is producing an result of noun or knock error, knock error. And so that's what we're getting back now in the jet, the mink jet.
We can go back to apparently I never saved the file. It should be in my buffer still. Did I put it somewhere else?
The mink jet?
Yeah.
If you can't find, I can just copy paste the contents to you on Urbit.
Oh, I just put it in a different non-directory. Oh.
Oh yeah.
Okay.
Yeah.
Okay. Then, so interpret's going to produce something, and what we want to say is if let okay res, then we have an answer, and we want to produce. I don't remember the syntax for this. It's like this or something. It needs like a stack or something. Chat, so, example.
Oh, the one for the cell.
Yeah, it's stack, and then I forget if there's one just for cells or if we only use the tuple, whatever. This, right? Except, so it's a result of noun and that, so it's okay that. Right? If we got an answer, it's that. Otherwise, whatever knock error, like sorry, jet error, which probably determines non-deterministic. Or no, sorry, it's gonna be okay anyways.
Yeah.
In theory, any of these should be okay. So it's gonna
Right.
be like this, except well, okay, so it's then we have a couple more cases, right? It's if or match, right? Probably. I think that's just the word. I'm forgetting it.
Yeah.
Match error res. So
I think it's match error res. Because it's just going to default unbox res.
but will it default on box res?
Yeah, I think so. Let me double check on the Rust book.
It might.
Yeah, where is it? Um, we should highlight this stuff better. This is I'm not sure where to send it to you. Do you want it on Urbit?
Sure.
Okay. So where's what that was right. There he is. This is what it's got in the Rust book. That's kind of ugly. All right. Good enough. So you do error and then parentheses, I guess res, and then tis gar match error or res dot kind.
Okay, yeah, that makes sense. Do the whole thing in like basically just do two separate matches, and that makes sense. We can do it directly on this. Yeah. Okay, so match this okay res goes to this. All right. Yeah. Or this, essentially, right? Let's see. A little weird to use the word error, so do that. Okay, I think that
Alex,
that feels pretty clean. Yeah.
Yeah.
Okay. Then, and of course, it's possible to do like let res is this, and then okay, and the whole thing, so I'm doing each of them, but I think this is fine.
Yeah.
Okay.
So and the question with that one is, for now, should we define a new stack? Right now, we're reusing the stack in there. Can we reuse the stack?
Right. So, okay, right on the outstanding questions while we're thinking about them. So, can
Sure.
we reuse back like this? And then I have something else in mind. All right, interpret should accept stri function.
Yeah.
Option of stri function. And potentially, produce block. I think it's gonna
This one,
need to handle 12 until. Go ahead.
this one might be solved for us with the proposal to remove the scry handler.
Yeah. It maybe will, but it also might take a really long time before that's real.
The silence said it all. It's one of those, yeah, moments. Okay, so can we use the stylus? We should be able to handle scribes. Is there anything else? I think that's the only open questions I can think of for now.
That's pretty much it. Okay.
Can we reuse the existing two stacks, or do we need can we just add a new frame on there, or do we need to create a new two stacks environment?
Right. Okay. So what does this do with the stack? It says put something on it as it is. If we get all the way to here, then it will have popped all the way to there. But if we return early, then it will not have popped far enough.
Right.
Right. And so
we need to, at the very least, record the state of the frame once we get into the jet.
Yeah. Okay. So what? Let me refresh myself on stack.
Oh, quick comment to add on there. What do we do with the noun? Because before this, the noun is going to be allocated somewhere, whereas now, if we have a trace, it exists on the stack, but part of the stack trace is now.
Yeah, interpret is going to need. I think interpret when it exits early is going to need to do a couple of things. So write this down first. Basically, it's going to need to gather that trace together,
Mm-hmm.
And produce it.
Yeah,
it'll need to sort of take it or whatever, preserve essentially.
Yeah, we'll need to preserve. We'll need to preserve the stack trace.
But preserve it not just one level up, but all the way up.
I think it should just calling preserve. Sorry, I think just calling preserve on it should work because it will. Oh, the relationship is usually from a really junior frame down. Will it still work if we've kind of jumped back and we're going up from more senior to more junior? And I think it won't, because the entire idea is that Senior memory never points to junior memory. Junior memory only points to senior memory.
Right.
So yeah, we will have to somehow recognize an error is happening. This might be an interpret that we'll have to do that. We might have to preserve the stack trace once we realize that we're going to need it.
Yeah.
And we need to preserve it to the home row, like the most senior frame in our stack.
Right. So it's also going to, yeah, some of this stuff's going to be a little weird.
And
Basically,
luckily,
we don't
go ahead.
currently have a long jump concept. I think you definitely could build one, but it might be easier actually to just keep preserving and popping until you get to. So basically, instead of, so in the beginning, record the state that's in your, or like, yeah, record the frame pointer or whatever it is that we're going to use as our, place to jump back to. And then ideally you would long jump back to there, where you basically just copy stuff out and go straight to there. But it might be easier at first to not long jump and instead just preserve and pop until you get there.
Yeah.
Like in a little.
Yeah. Just pop preserve all the way down until the root, at which point we now have the stack trace or the result all on the home row, the most senior frame in the two stacks. So
because that lets us know that we want to preserve, because like in this branch you would only be preserving these two, but with the trace you'd also want to preserve the trace in that case, which is different from each of these. Okay.
Yes. Okay, so actually it's not that bad. It's actually, I think, aside from this pop preserve thing for the early exit, the everything's working correctly approach will still end up, it'll automatically do that, which will end up with us having it on the most recent frame, which means we can return it. And in the pop preserve approach for the stack, we'll get it allocated on the most recent frame. So I think, yeah, so if we do that, we can do it, and we can reuse the existing stack for the two stacks, and they'll end up in the most recent frame.
Right.
Though this kind of ruins the thing Ed liked, this very nice property of being able to just look at the stack trace, like just look at the most recent item on the trace stack and just like return that, because it automatically forms a linked list. Now, since that linked list in the virtualized environment needs to be returned as a noun, now we're actually treating it like a noun. So now we actually have to pop preserve it, and we don't just use it.
I mean, the alternative is, well, it has, like, in some cases it has to be a noun because mink, literally produces it.
Yeah.
In like a non-deterministic case, yeah, you could just pull it straight off there before you pop anything, and set and treat it, or like, and operate on it, or like like print it from that.
Yeah. Exactly. Without the virtualization, the way that it was going to be used was just like send it over mute to king and then just obliterate the stack.
Yeah, which I think is fine for non-deterministic errors. But if we are gathering up the stack trace, and realistically we have to gather up the stack trace for now, we have to change a lot of Hoon code if we don't, then it has to be some way of turning into it now.
Right. So how do our non-deterministic errors work? Is it how much different is it from what we're doing right now for the deterministic ones?
Well, Mink doesn't care about non-deterministic errors.
Yeah, Mink
Yeah.
doesn't, but if we wanted to extend this system that we've got going right now, which we've got mostly designed, plus or minus like 10, 20%, what do we do for
There's
non-deterministic error
still
traces?
no threading through. There's no early exit from interpret. It has to like jump outside of interpret altogether,
Got
essentially.
it. So it just,
Well, there might be
yeah,
some threading through, like if if like a jet gives a non-deterministic error to you, you're gonna have to somehow say, hey, I need to kill this whole thing. But the answer is gonna be, I think, still to call the same function that you would call in a signal handler. Um, and it should, I believe, kill the thread that the interpreter is running in.
right. So I guess for
Um,
non-deterministic errors, we
yeah,
can still do this early exit thing where we just look at the trace that might go all the way through, minks as well. And then like it won't have the internal stuff of mink, but it will have mink itself. It'll have some error, just return the stack trace to king and then obliterate the entire thing. So okay, non-deterministic error should be fine.
yes, I think so.
Okay, so right now, just our last thing is how do we preserve the trace, which is going to be just preserve pops all the way up, or some version of that, and then I think we got the most important thing down. Now it's a kind of get into the like actual details when writing it. Like the important thing is we recognize that this needs to end up as a noun in the two stacks arena, like any other noun, like a result. Just that the
Yeah,
result might be, well, actually, yeah, that's what it is because now it's a send 0 or whatever. It's a cold atom of 0 or a cold atom of 2, and then either the noun cell whatever result or the trace as a tree or as a list, I should say. Everything's a tree.
yeah. Do you remember how I don't know, like a while loop, or if you do it with a for loop? Remember the for loops are powerful. Um, Basically, we want to loop until I'm supposed to do the stack here. We want to loop until the stack is basically stack dot.
I don't think stack exposes that. Is this the thing that you want to return the trace?
Yeah, like what I want to say basically is, you know, while this is not equal to until um, stack dot preserve, although let's see.
What is until? Like, what value do you picture it having?
Uh, we would save it here. Um, Probably right here.
Oh,
Until it's not a
oh, I
date.
see.
But this isn't quite working. It's like what is cache? Did cache get passed into us? Maybe it does. It does.
Maybe it's easier to just declare a new stack within this stack and then have the stack interpret a function, which is early exit, because then it can iterate on its own frame pointers.
Right,
If you see what I mean. Like,
you're saying put early exit into mem.
put early exit into, is mem the one I think of? I think
Yeah,
that's what I'm
the one
saying.
that
Yeah.
implements knock stack.
Yeah, I think put early exit into mem so it can iterate on its own pointers, and then inside of what we do is we make an allocation inside of our current stack, and what that allocation is just a new thing that we use for a new knock stack.
Um, where does it get the references to cache and res? And in the actual case, the trace as well.
So cache and res.
Because because what it's gonna, right, it's gonna need to do something like this, right? But it needs to like have a reference to cache and res.
Oh, so they'll.
And that is specific to the interpreter. It's not really a general property of the stack.
So they'll, if we declare the result is going to be. That's a good question. I need to think about this, but it's all in memory, so there should be some way to accomplish it, right? Like we're not actually moving anything out of memory. It's all.
But those are on the Rust stack. Those pointers are on the Rust stack. They're pointers into stuff that's in the Nock stack. But knowing what you need to preserve is something that only interpret knows. It could pass in a tuple of them. Can you have a tuple of? Well, they had to be somehow really generic. I don't think it can be that generic. A heterogeneous tuple of mutable pointers or mutable references. I think this probably doesn't work. What functions do we have on Nock stack?
There's honestly, a bunch of them. They're going to change quite a bit.
Yeah, but in frame might work. That's a public one, right? Yeah.
Yeah, in frame is public.
We could just say, well, you still need to store the stack pointer somewhere. But if you can store the stack pointer, well, if you can fetch the stack pointer, then that's all you need. You certainly don't need to be able to write to it. Or the stack pointer, think of the frame pointer.
It's just this until thing feels like what is until, like that's going to be a pointer, right? And we're going to need to have Nock stack expose that somehow, and that feels incorrect. Like if the Nock stack is starting to expose what its frame or stack or allocation pointers are, it feels like it should handle the entire operation of working its way down, and the Nock stack should be able to preserve its stack trace on its own. We shouldn't have to manually do that. It should be able to preserve the stack trace on its own.
Trace. That sounds like an argument that it should be able to produce like its result, for example, on its own. Which
it's the how am I trying to say this? It's not that it should produce, it's because it's tracing on its own as it goes. So if something goes wrong, it should be able to. Well, actually, that's a good point. The Nock stack, should it even know about the?
Nock stack can't really know about the trace. The trace is a property of the interpreter.
Right. Let me think of my own thing because I haven't looked at it in a while. Because I remember adding a pointer for the trace inside of the Nock stack itself. And I remember this is an idea that Ed and I talked about, but now that I'm talking to you, you're right. The interpreter is the one that knows about the tracing. And it's the one that should be doing it. Shouldn't be Nock stack. Spot hints to produce stack traces here. So what am I doing in the interpreter? Action dynamic. It's sham. Where is spot? Here it is. Trace dot push. Yeah. So this, the interpreter should be forming this, not the Nock stack.
Right, because the interpreter knows what needs to be saved at each pop.
Right. And then do I have how do I do the cleanup thing? Just stack trace pop. Yeah, this, yeah. Yeah, you're right. Yeah, the way you're describing is better. The way I did it in the initial draft shouldn't work that way, which is also good because this will make rebasing onto Jonathan's thing a lot easier.
Okay. Okay, that makes sense.
Yeah, your way is better. Your suggestion's better. Okay, so then, yeah, we need to keep track of some way that we can pop all the way back to the point we want to, which I
Okay,
guess
so my idea for that
maybe
then
levels
is
of depth or something. I think that's something better for the Nock stack to make explicit, maybe how many frames
but
it
we
has
don't
on
keep
it.
track of levels. Like we have to keep that as another piece of state, which is fine, but I feel like at the level that we're operating, it seems kind of okay to just say, yeah, you can access the frame pointer. There's not much to do with it, but you certainly can't set the frame pointer, but it is
The
there.
pointer, once you have it, you can do whatever you want with it. You start overwriting stuff.
I mean, it's U size. Or wait, that's not U size. It's U64. Uh, yeah. You can start overwriting things if you cast it to like a mutable pointer, but it's just U64. We can call it a frame number, and it just happens to be the pointer. Like the only operation you expect to be able to do on this is compare it.
Yeah, I understand we're not going to do anything stupid with it. It's just like, why? I'm trying to see if there's a way we can do this without giving people even the power to accidentally do something stupid. Like, you'd have to change what a Nock stack is to accidentally do something dumb with it. Whereas if you're getting something like you're getting the frame pointer out because the frame pointer is public, you might be like, oh, this is like, let me just start, somebody someday, let me just do this with it. Because like, well, I have it. Like, it'd be better to not even have it, is what I'm trying to say. I'm kind of trying to, what's the term for this? Defensive programming? Like, start out with the most
Yeah.
strictest permissions and loosen them up as you actually need them.
I mean, okay, isn't uh can't you still get it anyways with it, like it's local noun pointer -2, right?
Yeah, the fact that we have pointers at all means you also
Yeah,
have the
well, I
start of
mean, we
the,
have like this to me seems much more dangerous. Or I guess it's either -2 or +2 depending on its polarity. But if you choose polarity,
yeah.
it's public as well. Um,
Well, then my argument flips to, let's not make it worse. We should remove the danger of that one, not say its danger allows us to make things that are less dangerous, but still dangerous. If we have a
I
gun
think
lying around, it doesn't mean we should also have knives lying around.
yeah, my interpretation of this though is that like uh you know, or like there's a certain level of if this kind of thing is not only possible, but is the expected way to interact with the stack, because that is the way to interact with the stack, then um then it's kind of like, well, this just isn't a kid safe area. Um and like just the danger level, like if you're at, you're out in the desert shooting, having a knife lying around is actually probably fine. Like the difference in the danger between producing a mutable pointer to a noun versus producing just a U64, not even a pointer or anything.
Well, it's not that
I think
it's not the cast that I'm contexting of what it should be. It's the idea that just some other way of telling the
you're right.
stock to
It's
pop
not
down.
it's not U64. It's a pointer to U64. Wait, sorry, say that again.
It's not that I'm saying we should. It's not the cast of what the type is that I'm contesting. It's the fact that we have access to the value, or in some cases a pointer to something that's being used for internal, keeping, internal correct operation by this Nock stack. If anything, to be more logically consistent, I made a note for myself based on what you just said that I should go another round through John's PR for his refactor of the two stacks and actually look for things that are pub, which should be not pub, which I did a little bit, but I didn't look at every single pub function and go like, oh, why is this pub?
Yeah.
I guess I want to make a kid safe area in our desert shooting range.
Yeah, and I think that the stack, in the way that it's written, is just never going to be safe.
Well, the stack it's okay for it inside of itself to be unsafe and crazy. I'm saying that the way the interpreter uses it.
No, but I think it can't, like it relies on, for example, like it relies on you being like correctly preserving and popping. It relies on you using only local noun pointers that you actually have. That although I think John's work modifies how that works somewhat. It relies on you having pointers in a bunch of places. And so I don't think this is out of character with how the stack is meant to be. Like you're not meant
You have pointers to nouns.
see it as a black.
You have pointers to nouns that you're just using the Nock stack to store. You don't have access to you don't have pointers to the actual like management that the Nock stack is doing for its frames.
I mean, we just blindly cast them into mutable noun pointers. You could certainly cast that to anything else.
You could, just like you could divine which piece of memory is holding a really important pointer and just like overwrite it. But I'm trying to make it say you can't. You're not supposed to do this. It's immediately wrong. If there's something you want to do that modifies
that's what
the
making
state
this
of the Nock stack.
Const pointer, like a const pointer says that. It says don't change this, right? Unless you cast the const pointer to mute, which I don't even know if that, I don't even know lets you do that. Probably does.
I think you mean a pointer to const, right? Like a pointer to a constant thing.
Yeah. I mean tar U64.
Yeah, I
which
think that's
notably is
fine.
Is different than the actual. Obviously, frame pointer is pointer to mutable, or is mutable pointer to U64. Even that, but yeah. But my point is, this is a constant. I mean, it's a constant pointer to a constant thing. Constant pointer thing doesn't really matter though. It's the.
All right. Well, in that case, I think that we're starting to get a little too deep into it. So in that case, how about for now, we'll do it the way you're describing, and then I'll either
if you can find a nicer way, we can definitely change it.
Yeah. I'll either I'll just do it the way that you're describing for now, and then I'll add either another commit on top of that at the end, which is like, here, I want to do it this way because it feels safer or something, if I find a way to do that, or just start a discussion about it in the PR, in the draft.
Uh-huh.
But for now, we'll just get it done in the way that's like, let's just have it kind of like you're saying, like let's get the scaffolding up and let's just do it, and then we can have a debate once we have a working version.
Yeah, that sounds right. Yeah. Okay, so in that case, so this idea is we save the frame pointer.
Mhm.
I think we do it before the push. Could be after, but I think it's before. And then we I don't know if it's before or after. I'll make a note. And then when we want to return early, we call this before returning. We say early exit, stack, here's a cache, here's a res, at some point the trace as well. And here's the virtual frame that we're going to. Probably better be in the other order. And that should pop us all the way to the top, and then we say, okay, return to be a trace there. Actually don't even need to preserve res or cache. Because if we're early exiting, if we're early exiting, we definitely don't need to preserve res. We could preserve cache. That's a siglots cache, I think. But I don't think we.
That'd be kind of cool. Like, we wouldn't lose stuff within a road. We'd lose stuff within an event. That's kind of cool to keep it around.
Yeah. But res we definitely don't need.
Yeah, res we don't need. We need the trace, we need the cache.
Yeah. And so then basically, it's just that everywhere.
Yeah. And then that will return it to interpret, which is called from inside of the jet interpret. So it'll return that noun, which will be somewhere in memory, still on the stack. Yeah, okay. I think I'm gonna need to, when I'm fleshing this out, play a little bit with the pointers to make sure. But yeah, it'll still be on the stack. Then that'll get preserved at some point as a result. Back down.
Yeah. That's a one of the to do. That's like access these what's the working because we have to call early exit. Well, or yeah, okay. Actually, you know what's better? Just as a structure is don't put early exit everywhere. Instead, let
Wrap the whole thing in a let
equals that, yeah, essentially, and then say whatever it is, match res. I can't use the word res. That's already used for something else. Results or a tone or something.
Yeah. Anything will do for now.
Then say okay, res is okay, res. I think there's a more rusty way to do this, but this is it's not 0 specifically, it's just I guess it's actually just this.
Mhm.
We want to early exit both, but we only have a trace of one of them. So it's like that, I think, and we actually handle them separately. What do we call the other one? Which is the place we mentioned this in the yeah. For now, that's just that. But the other case is different. The other case is
Early exit.
or no, actually, we definitely need early exit in both cases. It's just we might be saving a trace, we might be saving whatever else, but we definitely need early exit in both cases. Okay, so it's
Actually, yeah, it's true. Yeah. Right. We preserve it anyway, and then we might not use it.
yeah, you could make it like optional, like I don't know.
Well, yeah. Right.
Lots of
Right.
ways to structure it. Block is a
We'll
pretty
optimize it
uncommon
later.
case, anyways. But
Yeah.
and then we actually don't need to match. We can just do error, which is that, right? And there's probably actually a simpler way to do that. And Rust format is gonna move all this over. Maybe should. Oh. And so now, yeah, all you have to do is return error from there, and we'll say if it's okay, it's okay. Otherwise, early exit, and then produce what we got. Various things will probably change at some point, but that seems like the right structure general.
Yeah. So this sounds good. So I'll share this with me on a branch for Aries, and then I'll take over, flesh it out, and then I will try to add mink or anything that might be downstream of that into the what do you call it? The cradle, the pill.
Oh yeah, yes.
Yeah. So and I'll try going with that. Actually, I might. Well, I think what I'll do is I'll. Oh shoot! I guess there's no way to do that yet. Yeah. Okay. I'll just.
If
I'll do it together.
you like one shortcut you can take, because so mink is gonna, well, how much mink depends on other things. It actually might not depend on that much.
Yeah. I want to.
But it does it does depend on a decent amount of stuff. What you can do while you're focused on getting the jet is just like create a mink that has the right arguments and return type and make it be zap, but as long as it's jetted, then it'll be running the jet and it'll be fine. And we can use that until, at some point either we pull mink into there or we get to the point where we're trying to actually run a ship. But yeah.
This will be cool though. This will be cool. It's getting us. I don't know. I just like that this game is pretty close to being able to run a ship.
Yeah, I think that's the whenever you feel like you're going in circles, it may not always get you out of it, but if you can stop to think, well, okay, what's the fastest way to get from here to running a ship? I think this gets us a lot closer once it actually filled out and actually compiles and stuff. Then yeah, having mink work is a big deal. The thing this leads most naturally into my perspective is then trying to handle all the non-deterministic errors, which means actually putting in a thread and correctly like killing that and gathering stack trace and stuff, which shouldn't be that hard. Yeah, nice.
Nice. Yeah. Thanks a lot for your help today.
Yeah, yeah, no problem. I feel like it might be good to do this regularly. Maybe we talk about this, but like,
Yeah. I think
we can plan to
we
do it
talked
next
about.
week, and then I will be out the week after at reassembly. I forget. Are you coming to reassembly?
Yeah, we could do a.
Nice.
If you want to, maybe a reassembly. I don't know how much time and who's speaking with what, but maybe a reassembly. We could do one of these live.
Ooh, yeah, yeah, that'd be fun actually. Do you know
Just,
is Ed coming to reassembly?
I think so. Get a 3-way live
Nice.
Aries work session. That'd be pretty cool.
Right. David, it sounded like might be able to make it as well.
David seems to
We'll
be
see.
50-50. He seems to have some
Okay.
sort of like personal commitment that may or may not occur.
Okay. Yeah. Yeah. Well, we'll see what we can do.
Cool.
Alrighty.
Nice. Yeah. In that case, I think you scheduled this one. Let me schedule a recurring one for us.
Cool. I'm gonna stop recording.
Sure.